guess, so the trial particular solution, what does that, I guess, form look like?
Oh, those were my pens. Dang, you guys, I can't read that. Is that a negative one half?
No, get it. You've got like number 3 question mark. Is this number 2? But this looks like, so where I have number 3 right here, right? Nice to see back. I have my integral set up, which is from there to x of sine of ln of a t over t.
Well, you got number 2 here. It looks like I realize it's not number 2. It's like I graded it twice.
And this is 3 continued. But this is 2 continued. But you see, I kind of labeled it a little weird.
No, I
Oh,
think
no. See, this is number 4, continued part 2.
Well, I didn't know that. I mean, I just see the number 2. I started, everything was all over the place, so I had a hard
Well,
time.
I know it's a little weird because all these things went on for so long, but can I talk to you about that after class? Because I think there might be some errors there.
But you guys, Michael, your
Okay.
question's on the particular solution.
Because it all looks nice
So
here.
let's talk about the particular solution. And I think the particular solution is going to have to look like something like this. Jeepers, guys, I'm so slow.
Awesome.
Will you guys get quiet efficiently?
No, it looks good. No, except not. Yeah,
What's that?
where's my problem?
Oh, yeah, okay. I just wasn't going there yet. You're going to stay with
So links. Well, you're going to have an x in there
How do you know that?
because there's duplicity in this one.
Okay, do you guys see my point?
Yeah.
I don't have the right to skip everything and say, let's talk about the trial particular solution. I've got to generate the complementary solution first to see if there's any duplicity. That's the real issue. All right, I'll take my break. I think when it comes to the auxiliary equation, I've got an r squared plus r plus 1 being equal to 0. Doesn't that necessarily imply that r is equal to, I don't know, is that a negative 1 plus or minus square root of 1 minus 4 all over 2a, which is negative 1/2 plus or minus root 3 over 2i. Oh shoot, look at that. There's duplicity. I think my complementary solution looks like the following. It looks like an e to the negative 1/2 x times c1 cosine of root 3 over 2x plus c2 times sine of root 3 over 2x. All right, so I blew for the trial particular solution. I'll fix it. You happy? I'm not either. I don't think I've made a mistake. I just think there's a lot of work. I got the product of 3 completely different functions. Just to differentiate once, I have to use a product repeatedly. Do you guys see my point? I think here I might want to give up. And just imagine I've got a complex valued DE. And therefore, maybe come up with a complex valued trial particular solution, which I think would be nothing more than some constant a times x times e to the negative 1/2 plus, is it root 3 over 2i? Just to make my life easier. Oh, did I just make a mistake? You guys, this doesn't seem to make sense. I've got 2 constants I got to find over here, but here I've only got 1 constant. That sounds like it's not going to work. You see my point, logically speaking? So do you think when I gave you this technique, I just blew it? Nobody must answer the question. I mean, does it sound like I really made a mistake when I taught you this technique? Because here I get to find 2 constants, but over here I only find 1.
No.
Yeah, I think I'm wrong. Over here I still think I
fine.
find 2 constants, but after all, when I'm finished over here, I find the a, it's going to be complex. When I multiply back in to here, then I separate the imaginary and the imaginary and real components, and that's where I generate those 2 constants. So it is no mistake. That's why there's no discrepancy here. But you gotta confess, once I look at a trial, a particular solution that's complex, at least the differentiation process is a lot easier. So if I were to try to differentiate once, not bad. I get the first times true the second. Plus through the first times the second. If I differentiate a second time, I see, let's see, with the first one, I guess I'll differentiate the second times the first as is. Would that give me a times this squared? But this squared would be a 1/4. Minus 3/4 was it negative 1/2? Is that a minus root 3? Over 2 times r. Plus, the second times the derivative of the first, but I'm going to multiply by the derivative of this as well. I think that's going to give me an a times, is that a negative 1 plus root 3i? Now, picking those three pieces up off the import, slapping into the original dE, oh, jeepers, that's kind of nice, isn't it? All those coefficients are 1s for the y, y prime, and y double prime. Yes, Chris?
Your second sum, what happened to the denominator?
I did this, I skipped some steps. I didn't finish the product rule yet. So I've got the first times true to the second, but that's just this. But I have to differentiate this. That coefficient comes down, it's the same as that coefficient. So I just doubled it. I just skipped some arithmetic because I don't know.
Well, if you double it, shouldn't you have a 2a up front? Of the second term here. So if you doubled the a times negative 1.
Well, if I have
okay, you doubled inside.
Yeah, is that okay?
I see it, okay.
In a sense, I just distributed it to him.
Yeah, I didn't see that.
As long as you're happy. And when I pick these three pieces up off the import, slap into the original dE, I think I get this. So substituting back, you guys just yell at me from skipping too much, please. So substituting back, I think I'm left with my second derivative. Plus my first derivative. Plus my original. Oh, hold it, I didn't write my full first derivative, I skipped a term. I've also got an a in there. Plus my original function, which is plus an a times x, is all being multiplied by a. If you don't mind, I'll divide both sides by the exponential factor, and I think I'm simply left with a 3 over here. All right, you guys, it's cleanup time. As far as the coefficients for x, as far as the coefficients of x are concerned, let's go ahead and deal with those next. In green, I'm looking at the combination of these terms. So here I go. I think a negative 1/2 x minus 1/2 x is a negative x. Plus x is gone. And I think my negative root 3 over 2 times ix plus is additive inverse. It's going to drop out as well. As far as the constant terms are concerned, I think the negative 1 and the 1 are canceling, and I'm merely left with a root 3i times a being equal to 3. So a is going to end up being, I don't know, what is that? You guys have a negative root 3, I think, times I. And if my math T skills are okay, I get to pick that up and plug it back in for ZP. And I think that tells me the following, that I have sitting in front of me a negative, you know what, I'm not going to have enough room for this. Can I start over? Let me jump in over here. So I think that Z sub P becomes my A times my X times E to the power. But substituting in that A constant value that I found to be negative root 3i, here it is. oh, you guys, I don't like it. I can't identify clearly what the real and imaginary components are, so let me just distribute. And if I distribute, I see that what I'm really left with is nothing more than, cheapest, I don't know what I'm left with. X times e to the negative 1/2 x, in parentheses, I'll distribute this in. And distributing in, doesn't that give me a negative root 3 times the cosine of root 3 over 2 times x times on? But I think multiplying to the second term gives me a positive root 3 times the sine of my root 3 over 2x, if I'm not being too sloppy. So I think this is a component of my real part of the solution. Here's my imaginary component. Which one do you want me to grab? Yeah, I think the imaginary component, because the original dE had the sine function, the forcing function's position. So I think my z sub p, or I meant y sub p, is going to be nothing more than my, is that a negative root 3? Times x, e to the negative 1/2 x, times the cosine of my root 3 over 2x. That'll be the particular solution. I will add it to my complementary solution to generate the general solution. But you guys, I answered that question pretty fast, didn't I? Maybe 5 minutes max? I don't think it's that fast. Michael?
Could you also go over number 2?
So, I think I got the right answer to number 2, but you confused my 2 with my 4. And so I think I've got like a lot of extra points owed to me here.
Oh, don't tell me
I'm
that,
gonna have to
please.
show this to you after class. All right, no, you confused my 2, my 3, and my 4. They're all mixed up and around.
Yes, can I just grab the middle board?
Disable and let's scratch number 2. You said what is this?
See, you didn't even grade number 2. You just kind of looked at 4 and said this is not 2, and
Well, was it my mistake?
yeah. So check it out, right? Where we go to 4. This is 4 continued part 2.
No.
But you
That
thought
says,
of this-
I read it as number 2.
I know you read it as number 2, but this is number 2 right here. 2 continued 1 and 2 continued 2. So I maintain continuity in the way that I.
Number 2
did
came
this.
after number 3.
No, they're out of order. I did them out of order.
Oh, yeah.
I know. You're the math guy. You're supposed to piece it together, right? I mean,
At 12 midnight.
at 12 midnight, yeah.
Permutation.
I don't want to permute at 12
Yeah, I
midnight.
permuted a problem.
Michael,
it-
I'm sorry. I
It looks
lost.
right,
It's not
though.
two.
Yeah.
And you thought the DE was difficult. Anybody, is this so familiar? Identical. The only thing changed was the constant up front of the hypothesis, I think. I did not intend that. I wrote this exam. I wrote it on my own. It's just after I wrote it, I started grading a quiz. I thought, oh my gosh. I think even the coefficient on the left-hand side were the same. I thought, no. I'm going to make sure I keep it on the exam. And I came to class that day and said, you guys, for the exam, please, I'm not going to go over this quiz. Look over it, make sure you really understand. I remember saying that in class intentionally.
Yeah, no, that's
So I was hoping
yeah.
that would be really nice points. Good for you guys. Okay.
Well, I was more curious about how to actually evaluate the intervals for UConn and New Year's.
Oh, and Michael, I didn't mean to push you off by saying I'm not going to do it. I'm just saying,
Oh.
I just want you to know. So you guys check this out. I think the complementary solution, you guys would be good enough to just list it.
Yeah.
C1 e to the negative x plus. Man, you guys are good at your math stuff. And therefore, to find the particular trial solution, I'll say y sub p is equal to a times, yeah, no, I can't use my method when determining coefficients. It's not one of my regular forcing functions. Well, not one of my special type forcing functions. All right, I blew it, you guys. I meant to come in and use the technique of variation of parameters because a forcing function is not one of the common ones. And so I think what I'm going to do is I'm going to allow y sub p to be nothing more than the wholly dependent variable u1 times my y1 plus my u2 times my y2. And I think this particular trial solution is going to have to satisfy the following system equations. namely that u1 prime times y1 plus u2 prime times y2 is equal to 0, as well as u1 prime times y1 prime plus u2 prime times y2 prime is equal to whatever the forcing function is. Isn't that just a 3 over plus e to the negative x? Pretty there. What's that?
No, it's
As long as I'm okay. And if I add these two equations together, oh, piece of cake, you guys. I don't have to finagle the coefficients. Adding both of them together eliminates my u2 1 primes. And I'm left with a 3u2 prime e to the 2x being equal to 3 over e to the x plus e to the negative x. Or shall I say u2 prime is equal to a 1/3? Actually, I just misspoke. didn't
Get
I?
rid of that 3.
I was cleaning up the coefficients for you.
1 over
So isn't
3 e to the x.
E to the 3x plus e to the x.
Yep.
Or shall I say u is a 2 is equal to the integral of, is that e to the x over e to the 4x plus e to the 2x?
Yep.
Or shall I say u2 is equal to the integral of my 1 over u squared times 1 plus u squared?
Perfect.
And now we just have to commit to just a tad bit, a tiny little special, easy partial fraction decomposition. Oh, jeepers, I don't know, you guys, what is that going to end up being? Is that a 1 or a negative 1? Somebody's pretty keen, isn't it? You're laughing at me. Yes, sir.
When you divide out both sides by e to the 2x,
Yes.
I basically it's 3x plus e to the x.
Why?
Splitting
Because I think when I do, I get this.
the negative.
Well, careful, I divided both sides by it. So is my arithmetic right? You just tell me, I make the same mistakes. And, like the piece of cake, does this give me you choose,
Negative 1 over e to the x minus tangent inverse of e to the x.
So Chase, is that okay?
Yeah.
All right. As long as you're not moving.
I just don't see it.
And I think
Mike
from,
has a question.
yes, Chris? I'm so sorry, Michael, yes.
So for the u substitution, did you have u be equal to e to the 4x or e to the 2x or?
Michael, I skipped
E
a
to
lot.
the x.
I wanted to let you be e to the x. I was nervous, because I don't see a derivative upstairs.
Right, I understand how you get from that to the e to the x on top.
But I did that so that I could make a substitution, u being equal to e to the x.
Oh,
And that's where the u squared, or u to the 4th plus u squared came from. So Michael, I think with the substituting u equals e to the x, this becomes 1 du. U to the 4th plus u squared. I factored out u squared. As long as you're okay. And everybody, you check out this equation right here with the 0, not the u. With that equation right there. I think since I already found u2, I can proclaim that u1 prime is equal to, is that a u2 prime e to the 3x? Uh-oh, I'm wrong. It's got a negative sign out front. Does that fix it?
Oh.
Which means u1 prime is nothing more than, well, here's my, if I multiply this by e to the 3x, I get
no.
a mistake.
Nothing.
I'm going to really multiply e to the 3x to u2 prime, which actually is over there. So if I multiply that by e to the 3x, actually negative e to the 3x, doesn't that give me this? Isn't that nice? No, it's not that
No.
nice.
Because you have a e to the 3x up top.
Does that fix it?
Not entirely sure what you did. Why don't you just have an e to the 3x up top?
All right, I'll do it your way.
And then
So
I,
e to
and
the
then I just,
3x over e to the, is it 3x plus e to the x?
yeah, and then I just divided each, or the numerator and denominator by 1 over e to the, x, or, right? Yeah, 1
Having
over e to the x.
2x.
Huh? Well, because I wanted to have an e to the 2x in the numerator, so I could just set the denominator to e to the 2x plus 1, and then I can make a simple u sub, and it's just like a, see what I'm saying? Well, no. You set your u equal to e to the 2x plus 1.
Oh, that's smart. Oh, that's pretty nice, yeah,
I know, right?
yeah. You did the same thing I did.
That's what you did in grade.
What was that?
Nothing.
But you get the same thing,
Yeah.
no matter which way you do it.
Yeah.
But Michael, I finally get to your question, which is, how the heck do we put everything together? So I think at the end, I can't do this without glasses. I think in the end, then, I want to proclaim that my y sub p, if you take a peek at right here, is going to be nothing more than the following. It's my u1, which is this. You guys, that is my u1. Times this exponential factor. Plus my u2, which is right there, is that going to be a negative 1 over e to the x? Minus the inverse tangent of e to the x. Oh, hold it. I've got that factor of e to the 2x sitting right there. Now, I have to confess, I get a tad bit of cancellation here that's just simply going to reduce to e to the x. And then I'll add that to my complementary solution. So I maintain that my general solution to the original DE is simply going to be that complementary solution, which is, sorry, it's sitting right in front of me. So C1 e to the negative x plus C2 e to the 2x minus the 1/2 e to the negative x natural log of stuff. And then I've got a minus an e to the x minus e to the 2x, inverse tangent of e to the x. Putting everything together. Mike?
For when you're solving for U1,
Yes.
what is U? Is it e to the x or e to the 2x? Because I'm
Depends who you talk to. The way I wrote it, I intended it for it to be e to the x. So with my substitution, I allowed you to be e to the x.
okay. And so that's why it's U and U squared. Well, I mean, if it's e to the x, then why isn't the top also U squared?
Here's one. Because I think this is nothing more than negative e to the x over e to the 2x plus 1. Let me just shave off a factor of e to the x, put it to the side. So that when I look at the interval, if I allow u to be e to the x, this is du. Do you see I shaved off the factor of e to the x to join the dx?
Right, so you just split that up.
So that this can happen. Because that's how my du is related to my dx. So I needed a factor to save it forward. That's substitution. Katrina? No, just showing you. Actually, what I should do? I should check, see if I got the same solution I just came up with. Let's see, this is number 2. Yeah, it matches what I have.
How do you do the integral of u over u squared plus 1?
It depends who you ask. What I did was
Yeah,
this.
would you do?
If you allow me to take a factor of e to the 2x, I misspoke. Allow me to take a factor of e to the x and shave it off, put it to the side.
Yeah,
Now when I come into the substitution, everything inside my circle becomes a du.
yeah.
But that just gives you u over u squared plus 1. That's where that came from.
I know where that came from, but how did you get from there to?
To the next step.
Yeah.
I made a z sub in my head. And the z sub I made in my head was this. If I allow z to be u squared plus 1, then I think dz is going to be 2u du.
Oh,
So I'll put a 2 up front,
yeah.
compensate, and now I simply have a negative 1/2 times, actually, what is that going to be? Is that just a natural log of z?
Yeah. I see it.
And then back to 2 twice. I just skipped a few steps. Yes.
On the final, do people, as far as you know, do they like usually feel like they have enough time, or is it kind of working the whole time with no checking time? Or do you really know?
Whenever I'm on Fridays, everybody feels very comfortable with the amount of time. It's not an exorbitantly long exam. I just want to make sure I relieve the pressure. I give that time.
Because I was worried like working 6 hours straight, like no time to check.
Is it like
like,
6 hours?
I thought that's what you said.
I've heard that the test is really long from people who've taken it, but
It's a
Do we
final,
take a-
'cause I don't push you guys.
I hear
when
we,
you
get-
finish.
don't we get like a little break or something in there? Or,
That's my last test.
pizza break?
Pizza break.
Yeah. I didn't drop or replace the most.
So what can you do with Laplace?
I couldn't hear that.
So what can you do with Laplace?
Laplassing? Oh, you want me to cut to the chase? I'll solve some D's today. Very cool stuff. Can you answer this question first? You guys, look at the scores. Was the exam fair?
Well, those scores are skewed.
And I've had a couple who say, oh, you know, this exam I just didn't study. And that's perfectly fine.
I
You can
actually-
drop an exam, it's no big deal.
To be honest with you, I thought this was your easiest exam today.
The easiest exam.
Yeah.
Well, it certainly is the most straightforward exam.
Yeah.
I mean, what punches can I pull?
It's all
Give you a
algebra.
defective matrix, and that's about it. So I just don't think there's much leeway to be really fancy. I think you thought the forcing function number 2 was fancy when you took the quiz, but I was hoping you'd overcome that when I said, make sure you look at that.
You even told us right beforehand to check for duplicity. So,
Did I really?
yeah, when we were in the math center studying, you came in and
Oh, yeah,
Oh,
okay.
yeah,
That's
shouldn't
not
tell us
keeping
to
anything. I just remind you, you need to check your duplicity. Daniel?
So I don't remember if I asked this before, but what is the split on the final, like with new stuff and just
For you, it's a horrible split, because I think you've got a lot of material that's new. You're going to, considering things like non-homogeneous VDEs, which take a bit of work. Laplace transforms, which don't take a lot of work, but it's a new topic. But also power series solution technique, which is a bit of work and a new topic. Those are the big guns that are coming, that I think you need to worry about. That's a lot of material that's not on the previous exams that's going to be on the final.
so would you say it's like maybe 60-40 split or maybe?
You know, I could be more accurate after I write the exam, and I'll be honest and
Okay.
tell you, but I'm thinking roughly 50-50.
Roughly 50-50?
That's what I'm thinking.
All right.
50% new material, 50% on the first 4 exams.
And so,
That means it's a horrible lottery, you guys. It's a 6-unit class. The first 4 exams cover a lot of material. I just can't come to class and test you on everything.
Okay.
Because I don't write the final exam so you can take it in 6 hours. I write the final exam so you really could take it in a couple hours. I'm just giving a lot of leeway.
and so, would you set up, like, say we get a axioms in vector space problem?
Yes.
Would you set it up the same way as when we took our axioms test, where you just gave us the axioms?
Yes, I don't
Okay.
want to I don't
Okay.
want you taking the time that I have for the exam to just memorize the axioms and go through all 10 of them.
Okay.
I will say things like, well, here's a set that could be a vector space. Could you please check axes 3, 7, and 9?
Okay.
But don't memorize the numbers. I'll give you that sheet again, just like I did in the past. All right.
Are there any sections that we covered in class that will not be on the final? Like, absolutely will not be on the final? Because I'm going to start studying pretty much today. That's when I'm going to start doing my review. But is there anything that I should skip over?
I don't know. I will not ask you questions, section 5.2. By the final exam, I don't care if you know anything about transformations in R2. I just think it's too basic of a question to ask on a final.
What chapter was that again?
5.2?
5.2? That's the transformation chapter? All right.
I can't think of anything else.
Okay. Circuit problems are fair game, and
I won't ask anything directly out of section 4.9 to rank nullity theorem. To be honest with you, the rank nullity theorem is much more special in its more broad form than general rank nullity theorem.
okay.
But don't expect there to be a lot of these little questions. I mean, expect the questions to be combining topics, to really show me you know your stuff.
Okay.
That's all I can think of. So you guys, can you remind me what we do know about Laplace transforms? For example,